He is the Chief Technical Officer of Artificial Medical Intelligence. He has designed, invented, and implemented technologies and methodologies for improving both speed and accuracy of coding. And he has 3 pending patents for this work. Prior to working in the medical coding industry, he was working in the areas of artificial intelligence, speech recognition, and human-computer interaction. He has worked both at AT&T Labs and Telcordia in those technologies also, and he holds a PhD in experimental psychology from Syracuse University. Please join me in welcoming him.
Thank you for that introduction. Today I'm going to talk about developing a medical coding gold standard. I started thinking about this seriously about a year ago at the last CAC conference. For those of you who haven't thought about it, it's really useful to have a gold standard. Part of the reasons that were already mentioned by Dr. Flanagan this morning, it helps improve the CAC software as well as let us know whether we're getting close to being as good or even better than human coders. So it's a useful tool. So my first question was how to approach the problem. What kind of a problem is it? And, well, because probably I'm an experimental psychologist, I thought of it as a measurement problem because as an experimental psychologist, I think of everything as a measurement problem. So, for me, the goal is to develop a good measurement instrument as part of the standard. But what does good mean? Now, just let me step back a minute and talk about measurement just in general. If you don't think about measurement a lot, you may think of measurement in terms of a ruler or a barometer, a physical instrument that's used to get quantitative measure. But if you think about it, there's a lot of measurements out there which involve human beings making judgments, quality, people making quality judgments, wine tasters, for example, are all making judgments, and they then become the equivalent of a ruler or a barometer or whatever. And the key here is to apply the same standards that you would for a physical instrument as you would for a human instrument, in this case a coder, making judgments on cases and figuring out what codes should or should not apply. So the first question you need to ask is, what does good mean? Sounds like a Bill Clinton type of sentence. Anyway, what is a good instrument? Well, there's 2 standard measures of good. One is reliability. Let's think about thermometers because everyone's familiar with those. Your thermometer should work the same way mine does. If you and I both go out today and my thermometer says it's 56 degrees and your thermometer says it's 35 degrees, your first question is, what's wrong? There's something wrong here. Thermometers should give you consistent measures. They should give you the same measure from one time to the next under the same conditions. That's an expectation, it's something intuitive. Same is true for human beings. You want them to be reliable. If you give them the same documents, 2 coders with the same experience, they should code the same way. So, and they should code the same documents the same way, given the same documents 2 weeks apart. That's what you would expect from an instrument. The second thing we want to talk about is validity. This is the second way we measure goodness. Let's talk about thermometers again. This is an invention I made specifically for this talk. I'm thinking of marketing it. I don't think I'm going to get any sales stuff. This is called the odd-even thermometer. What it does is it takes a thermometer and reads it and then says, is it an odd degree or is it an even degree? If it's an odd degree, like 37 degrees, it lights the blue light, and if it's an even degree, like 46 degrees, it lights the red light. Basic problem, who cares? Nobody really cares whether their degree is even or odd. This is a problem of validity. The instrument should measure something that people care about. It should be complete and should measure everything that people care about. So again, we're coming up with a gold standard. It should be complete and should be, in this case, valid. Okay? So when designing with a gold standard, we have to keep these in mind, and we have to also keep in mind that there's a great deal of variability, as has already been mentioned this morning, in the way medical coders code. And by the way, it's not just medical coders. There's a half dozen studies that show it's true for everyone. Physicians, medical coders, anyone who's in the field. It's not a function of the person, it's a function of the complexity of the system itself. So it's a difficult problem. So one thing to do is to try to address some of the root causes, and one of the root causes is coder error, and I mean by any coder by that I mean anyone who codes. There's three classes of errors: overcodes, assigning codes when they should not be, misses, not assigning codes when they should be, and substitutions, basically swapping, coding code A for code B, and vice versa. How do we compensate for error? Well, one way to do it is to use lots of people in creating your standard. You assume that errors are random and there is no population bias, by which I mean the entire population isn't wrong in some particular way. So the errors kind of wash out in aggregate. For example, consumer product surveys are sort of like this. If you ever subscribe to Consumer Reports or read a Consumer Reports article, you'll see listings. People are kind of all over the map in terms of, say, car preferences. But you assume that on average, people's general abilities or general experiences with a specific car are going to sort of wash out, and that you get a sense as to where the true good cars are in these consumer surveys. That's why people pay attention to them. So using lots of people helps to compensate for the random variability between people. The other thing that you want to try to do is reduce the memory load on people. People forget a lot. I can say that from personal experience. So what you want to do is allow people to choose among alternatives rather than generate information. It's a standard, there's a standard finding in experimental psychology which shows that people are much able to recall or recognize the correct answer rather than to recall it. That's why multiple choice tests are a lot easier than, say, fill in the blank. So, with this in mind, I designed this methodology, which I call the Delphi Method of Medical Coding. I'll explain it to you briefly. You take medical records and you give it to a set of coders. The coders produce codes. We'll call that a code set. And then from that code set, we transform it into a voting form. And basically, the voting form is the set of codes that all these coders generated, and one column for yes and one column for no. Now, let me explain a little bit about the code set. If you have 6 coders and they all code, they're going to code differently, they're going to generate different codes. What we do is we take the conglomeration of all these codes and we stick them on a single form. So that constitutes the code set. And then with each code appearing only once on the form. So we have the voting form with a yes and no. Then we give this voting form to a separate set of coders in round 2. And we have them basically give them the same medical records, give them the voting form, and say which of these codes apply, which of them don't. And we tally the yes notes and the no votes, and this gets us towards the gold standard because we're looking for are those codes, those codes where the yes votes exceed some criteria. You can decide what that criteria is, 80%, 60%, whatever, but that becomes, if the yes votes exceed that criteria, then that becomes a code which should be applied to that document, and that becomes part of the gold standard. Okay? So, we developed a pilot using the DMMC. We used 5, actually I should say inpatient and outpatient records. We had 6 coders in round 1, 7 coders in round 2. All these coders were very experienced hospital-based coders with at least 7 years experience. Some of them had 20 years experience, so these were very experienced coders. They were all certified. Now I'm going to talk about the results. All right, so this is the round 1 results. Now, this chart takes a little bit of effort to understand. What I'm measuring here, what I'm saying something here is something about codes, not coders. So you can look at each code on that, you can look at each code that a coder generates and ask the following question. You ask, how many other coders also coded this form? Now remember, in round 1, they're just generating codes. They're given the codes, they're just given the cases, and they're just generating the codes. So you really want to ask now, given that some coder has assigned a certain code to a certain case, how many other coders assigned it? So I asked that question for each code that came out of the study. There were 60 codes in all that came out of the first round. And what was surprising to me, I knew there was variability, but this was somewhat surprising. 40% of the codes, only a single coder out of the 6 generated. And then we can see the number of codes where 2 coders generated the codes, 3 coders, 4 coders, 5 coders, and 6 coders. This big, tall bar on the left is the number of codes where only 1 coder generated it. Okay, so that's the round 1 results. Now let's look at round 2. Remember, round 2 was where they got to vote. What you're seeing here is I'm asking the same question, only asking the number of codes where the coder voted. Number of coders, for each code, I'm asking the question, how many coders voted yes for this code? Okay? Hope that's clear. So we here see that for 7 of the codes, 0 coders voted yes, and then for 5 of the codes, 1 coder voted yes, and so on up the line to all 7. Now let's look at the 2 together. What you see here is kind of the consensus. By consensus, I mean multiple coders agreeing on either generating a code or saying yes. It's moving kind of to the left, right? From round 1 to round 2, the whole distribution is sort of moving this way, which sort of shows that a consensus is being generated more with this yes-no method than just a single generation of codes the way it's normally done. Now this is something you would expect because it is the way that human beings kind of operate. People forget, people sort of will consider other information, if given that information, will evaluate it, and it's giving them more information. This is a perfectly legitimate way, this is a perfectly expected way that these results should have happened. The experimental literature in cognitive psychology would have predicted this. So, looking only at the round 1 results, the DMMC is a lot like traditional methods for creating gold standards. You've got multiple coders coding the same cases, and you're looking for consensus. But comparing round 1 with round 2 reveals that the average percentage of agreement goes up from round 1 to round 2, 49% to 61%. And actually, this is, even with this small sample, it's statistically significant. A lot of this may have to do with the aid to memory that occurs when you're given the codes and you simply have to check yes or no as opposed to generating it. 10% of the codes dropped out completely, and 20% of the codes had 1 or fewer votes in round 2. Evidence that greater numbers of coders wash out overcoding and substitution error. And also, it gave me some confidence that it wasn't just, I think, Phil, you mentioned this last year, the benefit of the doubt phenomenon. That there was some judgment occurring, that it wasn't just people saying yes, 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 yes to everything. So let's talk about the gold standard in terms of this methodology. There's a need to establish a decision rule which determines which codes will be part of the gold standard and which will be rejected. For example, we could say all codes where there's 80% or higher agreement will be part of the standard, and all codes where there's 20% or lower agreement will be rejected. And then all codes sort of in the middle, they're going to be considered to be ambiguous. And that's not a good thing. What we want to do is reduce that ambiguity to a small number. Well, I basically took the results and I said, let's just make a decision rule. In this case, I think I used an 80% criterion level and see what happens. But what you see is there's a lot of blue codes. Those are the ambiguous codes. Thank you. So there's a need to use more sensitive tests as part of the statistical tests. Using statistical tests as part of the decision rule is a good idea given the high amount of coder variability. But to increase the power of these tests, lots of people need to participate. Lots of people mean lots of costs. What to do? So I started thinking about this as an online game. Online games are being used these days to collect lots of useful information. There's this guy out in Carnegie Mellon, Luis Bonan, who's been doing a lot of this work. And the basic principle is that through a game, you incent people to participate and in the process produce useful work. And here's a couple of examples of previous work that's been done in the area. You can actually go to these websites and participate in the games today. The coding game, as we call it, could be used to collect the kinds of information that I illustrate in this study online. And you can imagine how you might incent coders and so on. For example, here's a round one screen. The documents presented, the codes are entered in the lower portion, and then they can get scores or maybe not if we don't have the scores yet. And it shows you, it tracks whether they've got hits, misses, or overcodes. Here's a round two screen where they're checking whether the codes apply or not. A check corresponds to a yes vote. And in fact, you could even indicate whether the codes were principal or the principal code procedure or principal diagnostic code as well. The blue codes are the ambiguous codes. And basically what's happening in the background is that you're collecting data on these codes over time and eventually, hopefully, getting to a point where the codes reach some sort of statistical significance and you can move it over from, let's say, a blue code to either, definitely yes or definitely no. So, in conclusion, here's some products that could occur out of the coding game. You've got, you can get the gold standard using this kind of method. It also serves as an early warning system for coding problems because presumably there are going to be codes in situations which are never going to reach consensus. They're never going to be definitely yes and no, definitely no, and that shows that there's some kind of problem in interpretation of the standards. Of the standards out there and their interpretation. And finally, it also provides, as a sort of byproduct, a national rating system for medical coders, because as you get a gold standard, you're also rating you're not only developing what codes should or should not apply to the documents, but you're also able to measure how well individual coders can use or not use, can apply those codes according to the gold standard. So you now have a criteria, you can now measure how good the coders are themselves. In conclusion, new methodologies are needed to create a robust gold standard for medical coding industry. The DMC represents, I think, a better approach to generating gold standards, and implementing it as an online game will allow the widest participation in the coding industry and will also produce a number of beneficial products. That's it.
Time for questions.
So I think there's time for questions. Yes, sir.
So can we expect to see a Saltire episode about the world of codecraft? It's a game or something.
Well, yeah, I wish it was that exciting, but we are putting it online, and it will be online within the next month or so, with the intent of trying to start collecting this data.
Do you plan to collect information about who's participating, or there will be a screen that says what kind of training you've had?
Yes, that's part of the registration information as well. Yes, sir.
On the training, how do you verify that those people are certified, really certified?
We don't have a way of verifying it right now. I guess we could build in a process for doing that. It's not clear to me, though, given the literature, that having people who are certified necessarily is needed. If you've read the book, The Wisdom of the Crowds, for example, it was on the New York Times bestseller of this last year. It turns out that group consensus, if you have a little bit of knowledge, is a perfectly legitimate way of creating standards like this, or knowledge and information. Basically, the way you amass information, especially if you're talking about lots of people, creates a mechanism for sort of distilling out what the truth is.
I think this is lovely thinking outside the box. One way to address the question about, well, what if you have a monkey sitting there, or somebody's 6-year-old. We did something similar with machine translation. We wanted, in this case, Hindi to English translations. We would get out there and say, okay, anybody who wants to try it can try it out on the web. One of the ways that we did quality control, some colleagues, some folks at Hopkins who did this. One way to introduce quality control, which is the tenor of, I think, the previous questions, is to seed the data with stuff that you believe you know the answer to. And then use that to make sure, and basically don't use it as part of your data collection, right? Use it in order to help filter out the people who don't have sufficient knowledge in order to get.
Yes, in fact, Von Ahn uses the same technique in his games. Yeah, in fact, we would use that. In fact, we could even put in bogus codes to see if people.
And make sure people recognize it. If there are howlers and the person doesn't recognize it, you can disqualify.
Right, exactly. Yes, sir.
I was wondering why you present the color of every category, definitely or ambiguous, to the person participating. Why are you biasing in that way?
The color is only, they only see the color after they have checked off. That's feedback after they have entered.
Oh, okay, good. So there's not bias there.
Right, no.
Oh, okay.
Yeah, I mean, and you need to provide them feedback because that's part of the incentive for playing the game.
I see. Oh, congratulations, you are right,
Exactly, and they get points. I can show you other screens. We have those. They get, like a game can be the highest coder and so on. Top 3 or whatever, and get points and stuff like that.
That's great.
And it's surprising, but people are. I mean, Von Ahn has been extremely successful in doing this. But people are really motivated to do this. So, any other questions? Yes, ma'am.
For those ambiguous codes, do you capture somehow the information, like what was the reasoning for them to assign the code to be able to, eventually come to a standard on those?
Well, all the information is collected in the background. I don't know whether we can't collect information from the participants, but I think what's useful about this is that we collected this in a database. And then we can give this to, say, a panel of expert coders and have them sort of do post hoc analysis as to why these codes are coming up as ambiguous. And, right now, I have parameters set in the system which says if after 100 coders have looked at this, it's still ambiguous. This is an ambiguous code, so there must be something really wrong here. And so now you can go back and look at the coding guidelines and say, what is it about the coding guidelines and this particular code that's causing this to be ambiguous? So you get lots of information like that, and lots of fruitful sorts of studies that can come out of that.
So one last question.
Sure.
HIPAA question.
Well, if you're talking about the problems with HIPAA and the cases that we use in part of the coding game, I assume that's the intent of the question. First of all, everything can be identified. Okay, so that's obvious. But we try to derive the cases from a variety of institutions, so we get even a greater degree of anonymity that exists there. These cases are presented to the coders randomly, so they can't look up and try to figure out things. So there's lots of safeguards put in place.
And what de-identification software are you using? Or are you doing manual de-identification?
No, well, we're using for these initial cases they were done manually, but we intend to use. We haven't really settled on a package quite yet. Because there's commercial options, and as I'm sure you know, there's also there's freeware which we could then alter to convert units. Yes.
I was just going to make a comment that I know you give the example about the consumer reports with the cars and things like that, but this is quite a bit different because it does require a level of expertise to do the coding. And if you have, basically I was going to say that I think there should be a way to validate that level of expertise, because if the first speaker talked about fraud and abuse and things like that, if you have someone that's coming from a group that has practiced fraud and abuse type coding, and they have given that information down to other coders who are participating in this online game, that's going to skew the outcome of what you're getting if you.
Well, it might if you had a small number of people, but I have to assume that that people who don't know what they're doing, or they're kind of an outlier, they're just going to be washed out. Remember, we're talking about scores of coders.
The other population, I was thinking, if this becomes popular to some of the schools that are training coders, that same thing can happen, and that population is going to be even huge. It's going to be a big population.
Yeah.
That day.
Yeah.
So my comment was that I think the expertise should be validated.
Well, we do ask for people to, when they register, we ask them to provide identifying information which is obviously not revealed to anybody else, but which we could use then to sort of validate them. So we know their name, their email, and phone number, we know where they live.
The cool thing is, because it's all about sort of detecting lack of consensus, then unless you have like a vast quantity of people trained to overcode, you're going to have a situation where for those codes which are potentially overcodable, like at risk of being overcoded, you're going to have a bunch of good guys saying, well, I'm sorry, I disagree on this one, there's no belong there. And so you'd exactly reveal, this method will exactly surface those codes that are more prone to overcoding controversy, and those that are like no-brainer.
But that would depend on who is in group 2 to validate.
Yes, you need enough people with a clue.
Right.
To counteract the ones who are.
The trick is numbers. If you get enough numbers, then, the people who could throw bias into the results are sort of washed out. Yes, sir.
Along with that question, the trick is numbers. What types of incentives are you proposing to get people involved at that level?
Well, you can imagine all sorts of incentives. I will say, first of all, that just the game itself can be an incentive. And I say this because it's been shown in the past to be the case. People want to know whether they are, how good they are, Here is a place where they can go and, in relative anonymity, figure out how good they are relative to other coders. And you can see that there might be, our sense is when we've sort of shown this game to groups of coders, they're incented to try it because they want to show that they are, top dog. Okay? I mean, and that's a common kind of behavior that occurs with these kinds of games. But there's other incentives that could be offered as well. I mean, you can offer small monetary prizes, you can offer iPods, whatever. Those things could be incorporated very easily. Anything else? Okay.